5.5 part number 2 is going to be making this disc with a number of different hole styles in it, this circular plate. And so we're going to do that and then make holes in a number of different styles. You can see that there's a through hole that's just a simple hole. This one is going to be a counter bore, meaning that it's got a larger circle and then a smaller circle inside and a flat for a bolt head to sit onto. This one is a countersink, so it's got angles for a different style bolt. This one is threaded, so it's got grooves inside for a bolt to go into. And then finally, the last one is a clearance hole. So we're going to have a 1/2 inch bolt head that has to go through there without touching. And so we'll tell it the size of the bolt, and the computer will make the hole the right size. So we're going to start out by making a disc that's 4 inches in diameter, 1.5 inches deep, and then we'll make each of the different holes. We'll make some points, and then we'll make the holes one at a time. So we'll go back over to Fusion, create a new design, and this one, I believe they want this to be called circular plate. So let's save this right away as circular plate. And create my sketch with the 4-inch diameter. And extrude it 1.25 inches. So we've got our plate, or 1.5 inches. Let's go back and fix that. Double click on that extrude number 1 and change that to 1.5. There we go. So now the first thing we want to do is, if you're going to use the hole tool, which is this tool right here, the first thing you want to do is place a sketch on the surface and then put a point on it. So we'll create a new sketch on here. I'm going to, under create, I'm going to pick point and put it right there. And then all of these are supposed to be the same distance from the center of the hole. And you can see that that is a diameter of 2.5, so it's 1.25 away from the center. All right. And now if I move that, it's going to stay the right distance away. But so it's constrained somewhat, but it's not fully constrained. Let me undo that. You can see it's white, which indicates that it can still move a little bit. I'm going to add one more constraint and do a vertical constraint. So from the center to that point, and notice now it turned black to say that it's fully constrained and we don't have to worry about it moving on us. The next thing, because there's 5 different holes, I'm going to create a circular pattern. So that's under create circular pattern. Click on the hole. So that's the object, is the center of that hole. And then the center point for my rotation is my origin. And I want 5 different points. So I'll hit OK. These are the 5 points that I'm going to use for my holes. So that's the only thing I need to do in my sketch. I can stop that, and now I'm going to select these points one at a time and create the correct different holes for each one. So the first one it says here, if you scroll down, is a through hole. It's got a 1/4 inch diameter on it. So we'll pick the hole tool. We'll click on this circle right here. I'm going to change extents to all, so it goes all the way through the part. And then this first one is simple, and I need to turn off these other things. Go back to simple, and then tell it that the diameter is 0.25. And there's my hole that goes all the way through the part. Right. Next, I need to use the next point, but they all disappeared. So we can turn it back on. Sketches are on, but if you expand that, you can see that the 2 sketches we've used so far have both been turned off. So I'll turn sketch number 2 back on so I can use those points still. Click the hole tool, and this is the next one. All right. The next one, you can see on the drawing, it has this symbol. This square here means that it's a counter bore. The top diameter is 0.75. It goes down a quarter inch. And then the rest of it is a diameter of 0.375. It goes all the way through. So first we'll choose counter bore, and then we'll set up the hole correctly. So here's counter bore. The hole goes all the way through. The top is 0.75, so if that's not what's already on your screen, type 0.75, 0.25 here, and then 0.25 down here. And now you can see there's a hole. It has a larger diameter, and then it has a through hole that's the smaller diameter. And so that's the counter bore. So let me save that because that's looking really good. And do the next hole in the next point right here. This one has this V symbol on the bottom half, so that means it's a countersink, which is angled, 0.75 diameter, and then a 0.375 through hole. 82 degrees is the default, so you'll never have to change that 82 degrees. So we'll pick countersink, the third one over. I'm going to tell it that it goes all the way through, and then the upper diameter is 0.75. Like I said, 82 degrees it'll pick for you, and then 0.25 at the bottom. So here's our countersink or our angled hole, if you have that style of a bolt that's going into something. All right, hole number 4 is a tapped hole. So I'm going to go back to a simple hole here, but I'm going to change the tap type to tapped. Tapped hole has the grooves for a screw, and so I'm going to say it goes all the way through, and then I'm going to scroll down here, and you can choose the type of thread. So this says quarter dash 20 UNC 1B in a depth of 0.75. So I'm going to change this, go back. This shouldn't go all the way through. It should go down 0.75. The designation is quarter dash 25, so we'll make sure we find that. That goes with a quarter inch size if a quarter inch isn't your default. So make that a quarter inch, make this 1/4 dash 20. You don't need to worry about the class, but it did say 1B on there. And so if I click OK, this one, it's kind of hard to see, but if you zoom in, you can see it has the grooves. But this one does not go all the way through. It's got a little angle at the bottom for a drill point. This one goes down 0.75 like the drawing said. So let's save again. And now the is going to be a clearance hole, and it doesn't show it on the drawing, but I do see down here that it says it's a hex head bolt that's a 1/2 inch. And so for that one, we're going to say that this one goes all the way through. Clearance holes always go all the way through. It's a simple hole, but it's a clearance hole. And so once you click clearance here, you get the choice of whether you're doing metric or ANSI. We'll pick ANSI. You'll get the choice of screw head. We're going to use a hex bolt. And then you get a choice of size, and it's a 1/2 inch. And then the computer knows if you have a 1/2 inch bolt, how big to make the hole. And so we'll click OK, and you can see we have the last one. So there are the different holes that we needed to make. If I change to a wireframe with hidden edges, you can't really see anything all that different. You lose kind of all the effects. But if you have it on shaded, then you can kind of see what's going on inside the part.